Welcome. We are looking at calculus and we are differentiating functions using the formula. So as you can see, we have y. If y is equal to ax power n, where a and n are constants, then dy dx is equal to nax power n minus 1. So this is what we are calling the formula. This is what we are calling the formula. So if we are given a function of this kind here, using this formula to differentiate this one, then we are going to have, let's look at the examples that we have. Differentiate the following functions by the formula. Differentiate the following functions by the formula. So we have this formula, dy dx is equal to nax power n minus 1. Using this formula, we have to differentiate a function of the kind y is equal to ax power n. Now, according to the way the formula has been made, you can see when we have a function of this kind, y is equal to ax power n, for us to get dy dx of this one, for us to get dy dx of this function, which we call the derivative of f of x, or the derived function of f of x or y, what we need to do to differentiate this one using this formula, what we need to do is we need to multiply this power of n by the coefficient of this. So as you can see, we multiply this power by this one, we get na. You have seen, this is where the n is coming from. It is coming from multiplying this by a. So it's n by a, we get na. Now this power, which we multiplied by the coefficient here, reduces by 1. The power always reduces by 1. Now, looking at the actual example that we have y is equal to 3x power 4. This is our example at 1a. So we have to differentiate this one by the formula. So according to the formula, we need to see a function of this kind. We need to see the value of a. We also need to know the power. So that according to the formula, we need to multiply the power by a. Then the power will reduce by 1. Once we do that, then we would have used the formula in full, or to the fullest. So this is the question. So using the formula, we have to know the values of a and n. So you can see n, which is the power, is 4 here, and a, which is the coefficient of x power 4, is 3. So according to this formula, we need to multiply the power by the coefficient. Then the power reduced by 1. Then we would have differentiated fully by the formula. So we say 4, we say, actually, we are getting dy dx. Then this power will multiply the coefficient. Then we have the x. Then the same power will reduce by 1 according to the formula. The power multiplies a, so that we have NA, then the same power reduces by 1. So we have the power multiplied by a, so that this is where we have 4 times 3, then the same power reduces by 1. So actually, our dy dx would be 12. When you say 4 times 3, you get 12 x power 4 minus 1, which is 3. So this is our dy dx of y is equal to 3x power 4. Now, this is our derivative. It has names such as derivative. It is the derivative. It is the derivative of y is equal to 3x power 4. It is also the derived function. It is also called the gradient formula. Okay. So basically, this is the solution for 1a. Let's look at 1b. Look at 1b. Okay, so according to 1b, we have y is equal to 4x power 2 plus 5x. Okay, so you can see, according to the function that we are given, this our function has 2 terms. We have 4x power 2 and 5x. So it has 2 terms. Now, our formula has to be applied on one term. This one has 2 terms. This one, 4x squared and 5x. So you can see our formula has to be applied on one term. So since we have 2 terms in the question that we have under 1b, we have to apply the formula on both terms. So let's apply the formula on both terms. So we have dy dx is equal to, okay, so let's apply the formula on 4x squared. So as we have been doing it, we need to identify the values of a and n. So n is 2 and a is 4. So we need to say NA. So we multiply 2 by A. So 2 by 4, which will give us 8. 2 by 4, which will give us 8. And we are going to write the 4. Then we are going to write the x, Then this power 2 will reduce by 1. So, on this first term, we have applied the formula NaX power n minus 1. Plus, then we also apply the same formula on this other term. So you can see, the way this term is, we have 5x. So the way this term is, x is raised to the power 1. Now, when x is raised to the power 1, we don't say x power 1 because we are able to see it already. So we identify again the values of a and n, then we multiply. So we have 1 and 5. So we say 1 times 5 is 5. Then we write the x. Then this power reduces by 1. So simplifying this, we have dy dx is equal to, here we have 8x, you can see the power is 1, so there's no need of saying 8, x power 1, plus, you can see here, we have 5x power 0. So finally, our dy dx will be given by, this one is done, so we have 8x plus, you remember that law of indices which says any number which has a power 0 is equal to 1. So here in place of x power 0 we have 1. So we say 1 times 5 we get 5. So basically this is our derived function, or the gradient formula, or the gradient function, or the derivative of b, y is equal to 4x squared plus 5x. Thank you very much for your attention.